around this fiber is non-unipotent, well, maybe it is unipotent if and only if X is rational. So that's just how to guess if you are right in this case, rational or not. Just calculating monodrom of for given pencil for polynomial. Another maybe funny example is the following. One may take all these polynomials for these 17 varieties, compactify it in the natural way. There is actually it's easy to guess what's the natural way for them, because for these cases there is some like minimal resolution. Compactify 5 weak Landau-Ginzburg models for such funnels. And just count the number of so the fiber over 0 is very reducible, and found calculate the number of components. Let K be the number of components. It's just it's number of surfaces, components over 0. Then K equals the dimension of Jacobian of X. So this actually I've computed it for not for all of them, but for 11 in some sense most difficult for compactification, but that's for sure it holds for all of them, and actually that's it's very natural from the viewpoint of homological mirror symmetry, but you can predict the dimension of intermediate Jacobian. So maybe okay.
The theorem?
This?
Yeah, that's a theorem.
Well,
Or you are assuming that.
Well, it's.
Unipotence?
Unipotence. You mean unipotence?
Yeah.
Yes, that's theorem, but.
Every fiber will be such a fiber.
Well, there is actually a unique distinguished fiber with non-isolated singularities. Well, this usually there is these models are, as I've told, it's several fibers with non-isolated with isolated singularities corresponding to exceptional collection in derived category, and the rest is usually non-isolated singularities over 0. Usually the fiber over 0 is the union of some components, and the singularities are the intersections. So there is a unique such fiber usually, and it's theorem, but it's I mean maybe it was never formulated, but it's just a very easy conclusion from calculation of Goloshev. It's not maybe, and this classification theorem of Vygotsky, which is hard, but you just may get two lists and check that they are. But well, that's it's natural from the viewpoint of mirror symmetry. It's just in high dimension, it's the rationality questions much harder. I'll just want to talk about it, but here you can. So the answer is yes. Still, some more questions? No? So now I want to the last 20 minutes. I want to, or maybe even shorter, tell the general strategy. It's so conjectural, but strategy how to study rationality problems using just this. So if you have a smooth the ideology is the following: let you have smooth you want to study if it is rational or not. What means rational? That this means that there is a sequence of blow-ups and blow-downs starting from your variety and coming to projective space. So mirror symmetry states the correspondence, homological mirror symmetry, in particular between derived category of your variety and monodromy data or singularities of or vanishing cycles, but say of dual pencil. But it's known you may control in some sense how derived category changes under blow-ups and blow-downs. So assuming mirror symmetry, you may control the changing of your Landau-Ginzburg models under blow-ups and blow-downs, and you may deduce some invariance, some monodromy. So for projective planes, monodromy is this monodromy around the. Yes, well, you mean in terms of polynomials?
Yes.
Yes, but I don't know exactly how, but very, very approximately, it's just you have your polynomial, you have some terms, and you should erase one of them or add. Very approximately. So for P2 it's 3x plus y plus 1 over xy, but for open P2 without a line, without boundary, it's just only x plus y, and without 2 it's just x.
But sometimes you have to add it, because you cannot remove all, right?
Yeah, well, I thought it's very roughly. So that's what you should do for open. So, well, just we erase one term for P2, and that means that we consider the model for open P2 without a line. Then, if you blow up something at your line, you have another polynomial for blow up, and if you delete this two lines blowed up, and well, I mean open parts of these two varieties, P2 and P2 with one blowout point, are the same, and so erasing from two polynomials terms, you get the same. So erase and then maybe add something. But I'm not specialist, I don't know. But there is a recipe, maybe in examples, and Katsakov should know because it's his approach. He told me that showed examples, but I'm not specialist in this.
But you want to show this general method? There's general.
I'm not sure, but it should be. Well, the problem is that there is a lot of conjecture. So if all of this is based on conjecture on mirror symmetry, that's for mathematicians. That's conjecture. So the problem, you can prove only modular this conjecture. So modular this and method, you can give methods only conjecturally a bit. I don't know, but Katsakov knows for sure. Is it his method general or just examples? I think general, because it's just like the same as homological mirror, generalized homological mirror symmetry. His study.
Okay, let's see. Okay, question? Then let's thank speak again.